Hello, Lewis.
Hey Merve, how's it going?
It's going great. How about you?
Yeah, good. It's today it's snowing like crazy, so it's a nice day to be doing question answering.
Yeah, great day to. Every day is great to do question answering. So yeah. So for the first session, this is a concept where we have come up with to make every session we are going to go through a course chapter of task. This one is for question answering. Next one might be in masked language modeling. You can decide it on our Discord, and our Discord is let me bring up the banner, hf.co/join/discord. And today we are going to go over the course chapter on question answering. You can ask your questions from here. Let's get started.
Awesome. So I thought what we could do today is focus a lot on more the sort of conceptual aspects and the data processing side of this problem, because the training of the model is in some sense the easiest part in question answering, and it's actually how do we prepare the data
Thanks to
for the
thanks to transformers.
Exactly, yeah. So I'm not going to probably train a model per se today, because I think that's kind of, once you get to that point, it's pretty much just feeding it to the trainer and you're done. But maybe it's nice to just start by kind of like asking ourselves, like, what is question answering, and maybe what it looks like in the real world. So I've got a couple of cartoons here. Maybe you can see this one on the screen. So most of the time, like when we talk about question answering in NLP, it actually means many different things. So, for example, the question answering that we're looking at today is something called extractive question answering, because the answer that we're looking for in the document can be extracted directly from the document itself. But there's other things like, for example, generative question answering, where you use a model like BART or GPT-2 or something like this, and you try to generate an answer based on some input prompt. And so these kind of examples are quite different from each other in flavor. And when you want to actually build question answering systems in the real world, building the model is just one small part of the problem. And most systems today that I know of, they use what's called a retriever reader system. So you actually have a retriever which takes a question from some person. So someone here is asking, when did Marie Curie win her first Nobel Prize? And this retriever is kind of like a search engine. So you can think of it as like Elasticsearch or any other, TF-IDF would also be perfectly fine. And then this search engine will just look through your database, because you might have millions of documents, to find the ones that are most kind of relevant for the query. And then these are the documents that are then fed to a model, which is typically a transformer. And then the transformer will basically parse these documents and try to extract the most probable answer. So in this case, the model says, Marie Curie got her second or her first Nobel Prize in 1903.
So in the
So
con- in the very, very basic terms, question answering models take documents and the question and actually look for the answer in those questions, in those documents, right? Like the very
exactly,
basic idea is. And this is where extractive question answering takes place, where we know that we can extract the exact answer, exact answer from the documents, as
Mhm.
opposed to the generative question answering, where the answer is generated, not extracted. So it is going to say something like, Marie Curie won her first Nobel Prize at 1903, something like
Exactly,
that, instead of directly saying the year extracted from the sentence.
exactly
Yeah.
right. And there's even other more interesting flavors that you might see. So if you go to Amazon, let's say Amazon.d, or actually, sorry, I'll do an English one If I go to the German one, no one will understand it. Okay, so if you look up a product like, I don't know, a Les Paul guitar, so these are like super beautiful guitars, and maybe let's pick one that has a lot of stars like this. Well, this is not a Les Paul, but whatever. So what you can often see on Amazon is they have a kind of question answering system. So if you look up here, people ask questions. Does it come with a bag or a whammy? And then someone from the community then has answered it. And so this type of question answering is called community question answering, because you're kind of asking questions and getting answers from people in the community. And in this case, instead of trying to extract the answer from some text, what you're trying to do is, if I have a new question, I try to find the most similar answer in my database. And so in this case, you might use something that's more like a sort of embedding approach, where you would embed the questions and the answers, and you do like a semantic search type thing.
Like sentence similarity, sort of?
Exactly.
Yeah.
Exactly. So you would say, okay, if I have a question which is asking about this gig bag, I would embed this as a vector. And then if I have a new question that is similar, then I would try to see, which answer is most similar to that question. And this is how, for example, when I type here, like, let's say, I don't know, something about, does it come with strings or something? Then you can see that it's trying to find the most common questions. And, in this case, it isn't a good answer, but you get the general idea.
I've actually used this once because I kind of found my problem was hard. So I thought that I could actually solve it like this, because like this actually works fine with, when you are not looking for exact answer, but maybe the context that your answer might be existing in,
Exactly.
what I mean? Yeah, like even if it's not the exact answer, like you get something similar that, your answer is possibly in this sentence, which is actually good. Like the model is trying its best, and I appreciate it.
Yeah, and one thing is, like, this is much easier to label because, provided you've already got kind of a question answering like forum or system like this one, then you don't actually have to go and check, the answer exists precisely in the document. You can just sort of,
Yeah.
kind of bootstrap the model on the community question answering.
Yeah, like we need to like mention that the question answering models actually expect data with their start and the end indices of where the answer is in the actual context, and the question and the context itself. So maybe for this case we don't actually need it. So which is, as you said, is easy to easy to do, easy to label. You are not even labeling, I guess.
Exactly. And so, yeah, just to sort of like set the scene and follow what you were saying, is like, if we now focus on just this extractive question answering task, which is the one in the course, then what you can see here is exactly what Merve mentioned. So we have a question. So this is the start here, where we say this is the question. And then we have what is called the context, which is typically the document where we think the answer would live. So this is all this stuff here, which says this is the context with blah, blah, blah. And the answer in general lives somewhere in this context. And the thing that we need to do is to predict the start and end of this span of tokens or span of words where this answer lives. And almost all of the work in question answering, or this extractive form of question answering, is how do you process your documents and your questions so that you can identify precisely these starts and ends. And so maybe with that we could start having a look at some of the code from the course, and then we can switch between slides and course as we go.
Yeah, of course.
Okay, so if you want to follow along, you can just hit this open in Colab button on the course here, and then this will open up the Colab either in PyTorch or TensorFlow based on your preferred framework. And in this particular chapter, we're using something called the Squad dataset, or the Stanford.
Maybe in in the Hugging Face Hub there's dataset viewer, and like it's best if we show it there because it looks nice.
Let's do that. Let's use it. So if you go to huggingface.co, you go to the datasets tab here. You can then search for Squad, and there are two versions of Squad. I'll explain what they are in a sec, but the one we're using today is the first version of Squad. And then you'll get like a little kind of sample of elements here, but you can also go to this dataset viewer link here, and this will then show you kind of in a full screen what we've got. So here we've got a couple of splits. We've got a train and validation split. And what we can see is each of the examples has an ID. We have a title about the document. We have this context where the answer might live. And then we have the question and the extracted answers. So if I click on one of these rows, what I expect will happen is it will expand. Yep. And so now we can actually see, the full text associated with this example. So this dataset, this Squad dataset, it's a very famous dataset that was developed at Stanford. And what they did is they took documents from Wikipedia in English, and they then basically chunked them into passages, so kind of like paragraph length sort of segments. And then in each one of those segments, they annotated a question about that segment, and then whether or not an answer existed or not. And so you can see in this example here, this is a piece of text about, I think, the Virgin Mary and I guess some miracles. So the question says, to whom did the Virgin Mary appear in 1858 in Lourdes, France? And so, as a human, you would probably read this text and you would go, where is it? Where is it? And then we can say, something, let's see.
Saint Bernadette somewhere. Yeah,
that's right. So we can see here, it is a replica of the Grotto of Lourdes, France, where the Virgin of Mary reputedly appeared to Saint Bernadette in 1858. And so you can see that the label is indeed Saint Bernadette Soubirous, and we're told here that the answer is sort of 515. And what that means is that if we just look at all the characters in this document, once we get to character 515, that's the start of the answer. And then we just have to add the length of the answer itself to get the end based on this text. And so this task is often called reading comprehension, because it's even though it's based on asking questions and extracting answers, it's also very similar to what you do in school. When you're asked to read some essay and then you have a bunch of questions about that essay, it's a very similar kind of task. And so, the one thing I wanted to point out, if we go to, there's a website called Papers with Code, which is great if you want to see kind of like what is the current state of the art. And I think if we look at Squad, I guess we're looking at Squad 1. Let's maybe look at this one. So they have a bunch of tables that are quite interesting. Maybe this, exactly, yeah. So you can actually see like the progress over time for this particular data set. And there are two kind of metrics that are used. One is called exact match, which is where you check that the predicted answer is exactly the same as the extracted one, or the ground truth. And there's also an F1 score, which is kind of like a variation of the F1 score you get in classification tasks. And what you can see, not so easily now because transformers are taking over, but there was like quite a big jump in performance from the time before transformer models. So you can see here that the exact match score was around 67 points. And then, now we look at transformers like Luke, and you're getting around 90 points in exact match. And so this is one of the sort of famous benchmarks which made like the whole field kind of go, wow, when BERT came along, because BERT was one of the big jumps you can see here of 87. And, the previous models, okay, they were similar, but they were based on, ensembles. And so here we had a single model that was the state of the art at the time. Okay, so we're using this squad dataset, and you can get this from the hub, as we saw, by just feeding in the squad, the name of the dataset to load dataset function. And this object we get back is kind of like a dictionary in Python, where we have splits. So we've got a train and validation split. And each one of these splits is now this like dataset object, which you probably have seen in other sections of the course. And so we can index into these objects sort of like as a normal Python kind of container. And you can see that, we have the context we saw before. This is the story about the Virgin Mary appearing to someone. And we can see, here are the kind of text data that we're dealing with. And there's also a validation set, which has, different topics. And the goal that we want to do is we want to process these inputs in such a way that when we're provided with new examples, for example, in the validation set, the model will actually predict the start and end indices for where the answer could be. Okay, so maybe we can have a look at the pre-processing. And before we do that, it might make sense to just have a kind of look at what we mean by, what is the model actually doing, and also trying to understand like what we actually want to extract from the data. So this is kind of a kind of simplified cartoon of what the model looks like for question answering. So you typically have like an encoder layer, which is very similar to anything you've seen with BERT and other models. And this encoder takes as input a sequence of tokens, so very similar to text classification. But the main twist is that we have a CLS token for the start, but we also have this separation token, which splits the question from the answer. So we basically concatenate the question with the context, and then we feed these together into this encoder.
Maybe you would like to explain the CLS token as well.
Yeah, sure. So the CLS token is a special token that's associated with a tokenizer called WordPiece. So that's actually in chapter 6 of the course. You can find all the details about how that really works. But for now, you can just think of it as a special token that we introduce to indicate the start of a sequence of text or a sequence of tokens.
It is sort of like containing the class, basically. Like when you think about like in a supervised manner, it just contains like information about the class and stuff. So that's where CLS itself comes from, maybe.
Exactly. Yep, that's right. So when you're doing classification tasks, like say sentiment analysis, or as Vincent was talking about last week, or the other day, people often use the representation of that CLS token as the thing that is the feature vector for your classifier, precisely for what you said. And so each one of these tokens will actually produce a vector called a hidden state. And these hidden states by themselves, they don't have tons of information at this stage yet. And so what we do is we then feed them through a linear layer, which is just like a kind of sort of fully connected network attached to your encoder. And the shape of that linear layer is such that we can predict for every token what are the logits, or what is, let's say, the probability that it is a start or an end token associated with the answer. And so every one of these tokens will have some different probability. And hopefully when we train the model, it will learn to identify which pairs of tokens indicate the start and the end. And that's kind of what this diagram is communicating. And if we go kind of one layer deeper, then what we're really going to do is we're going to take a sequence of tokens like this, and you can see that each token gets two labels. It gets a start and an end label, and we will indicate if the answer exists or if it's the start, we'll indicate it with a 1. So you can see here that the has the pink label is 1 to indicate that's the start. And then here on this token here, the end label is 1 because that's where the end of the answer is. And so the basic idea is we've got to somehow take all of these tokens, assign them 2 labels, start and end, and then train the model to work out which pairs of start and end correspond to the answer. So let's have a look at how this kind of first step works. How do we actually prepare our data to do this well? So here I'm just using Distilbert. It's a very popular, fast to train model. But in general, any kind of BERT-like model would be perfectly fine. And what I'm going to do here is I just feed in the question and the context as a pair into the tokenizer. And so if we then decode this input, we can see that we've now introduced the CLS token. And we've also got a separation token here, which is splitting apart the question about the Virgin Mary from the context where the answer might exist. So this is kind of like similar to what you probably saw in part 1 of the course, where we were looking at kind of paraphrase identification, trying to figure out if one sentence is a paraphrase of another. And here, the thing that we're doing is we're just providing 2 inputs to the tokenizer, which is a little bit different to standard classification tasks.
By the way, we have a couple of questions. Would you like
sure.
to answer them shortly? I didn't want to interrupt you. You were
No. Wait,
enthusiastic.
please interrupt. I think it's way more fun interrupting because otherwise it feels like I'm just talking into the void.
So there's a question. Lewis, you talked about TF-IDF for the retriever. How about retrievers that use deep learning like DPR? Do they outperform statistical models by a lot? Do they impose some new constraints? This is not that relevant to the context, just a little from the retriever, but yeah.
Yeah, that's a great question. So here, the question is about this part of the sort of real world pipeline of the question answering system. Mm-hmm. And what the question is about is there are alternatives to using kind of like statistical approaches based on embeddings, basically. And the sort of super hot topic for recent years has been something called dense passage retrieval, or DPR. And the idea with this dense passage retrieval is that you represent each one of your documents as an embedding vector and your query as an embedding vector, and then you kind of do like a similarity score on those 2 vectors. So from what I remember, DPR was sort of claiming that they had state of the art on some retrieval tasks. But I know that Niels Reimer at Hugging Face has a paper where he analyzed the performance of DPR at different scales. So like how many documents you have. And from what I remember, if once you start hitting like very, very large numbers of documents, you're much better off using a statistical method like TF-IDF, or BM25 is the kind of modern one. But I'll put a link to the papers in the Discord later.
How is this different from MS Marco passage ranking, by the way? Just a quick question. They look very familiar.
Yeah, so I actually don't know the answer between what is the difference between MS Marco and DPR.
I will check after the stream. I will definitely check.
Yes.
Another question, we have gone through it, but what are some useful metrics for the QA task, and with a quick explanation of how they work, please? And do we have a different metric for information retrieval? I think they are different.
Yes, definitely.
You can answer.
Yeah. So with information retrieval, the sort of, let's say, most common metrics that people use are kind of like precision and recall, in the sense that like you want your retriever to return documents that are relevant to the query. So that would be kind of your precision in some sense. But you, by the same token, you want to make sure that if an answer exists, that you actually collect it. And so that's sort of the recall side of the equation. And generally speaking, there are things called like mean absolute precision, which is like a twist on the precision metric that you're familiar with from classification, which basically tries to weight the quality of the return documents, or say the relevance of the return documents, in a way that is closer to what a user would expect. And then for the reader, or for the actual reading comprehension task, the metrics we talked about were on this papers with code. So we have this exact match metric. An exact match here just literally says, if I predict the exact span of text, then this is +1. And if I don't, then it's 0. And the F1 score here is kind of like a modified variant of F1 from classification, where you take your answer, your predicted answer, and you chunk it into like a bag of words. And then you compare the overlap of that bag of words with the bag of words from the ground truth. And then you look for the kind of, how many of those words overlap with the words in your ground truth. And that gives you a kind of like, precision recall type metric.
When you think about it, for this, like when you are doing F1 score in the extractive question answering, the point where F1 score might come wrong, might come less, might be that your answer contains some boundary words that actually do not belong to the answer. But I don't think like it would be the opposite, where I have never come across that, like where the answer answer is chopped or something, like the ground truth is chopped or something. I never come across that. I just wanted to say.
Yeah, I think what you said is right, is that in general, the exact match score will generally be less than the F1 because of this penalty, right? If you have a boundary word, you're just going to get 0. Whereas the F1 is a little bit more forgiving.
I would definitely use F1 instead, because it's usually like overrated, exact match. It's
it's a tough one. Do we have any more questions, or should we carry on with
there is like small questions. So someone, hello, I'm a data scientist new here. I want to learn more about Hugging Face. For now, I'm using a transformer within a Reza chatbot, Camembert. I want to expand my knowledge there. Any course you recommend? Do you often do live workshops? So we are actually going through the Hugging Face course. You can find in hf.co/course. And I've also done a chatbot with Raza using Hugging Face BERT models. Maybe you would get more answer over there, and also Raza's own Hugging Face pipeline documentation, just saying.
Awesome.
Are there other token you can label as non-important texts? I don't know about this.
So that question might be about this diagram where we talked about that for every token, we're going to assign a label of whether or not that token belongs to the start or end of an answer. So in the question answering task, that's the only thing you have, is just start and end. But the answer to your question might be more in the direction of like token classification. Like maybe you're interested in extracting different kind or predicting different kinds of labels for your tokens. And so if that's the case, you might want to check out the token classification chapter we have here in the course.
Also, we have Vincent here, and he's saying, got me curious. Got me curious. What is the intended use case for these question answering models?
Yeah, that's a great question. So probably the most common one that I've seen in the wild has been typically for like, let's call it like enterprise search. So no one really has access to Google in their company, but many companies have a lot of documents. And so the first thing that at least I've experienced is that you will typically have a search engine, which will allow you to index all your documents. And that will give you, let's say, the first part of this equation, the retriever. But then you might want to ask like more elaborate questions. For example, maybe like things that are quite domain specific. And so even if your retriever is giving you, let's say, 10 documents, if these documents are, say, legal documents, you still have to read, through those legal documents to find the answer. So I would say like most of the current use cases are kind of in this kind of like enterprise settings from what I've seen. And there is like a sort of nice example of this from a paper called Quad, where these researchers at Berkeley and elsewhere, they pointed out that in sort of legal contract review, there's a very tedious process involved in kind of extracting systematically answers to some common questions about legal contracts. And so they point out that like this is like a task that typically requires some law interns to spend their whole summer working through documents. It's kind of boring, but everyone does it because you need that domain knowledge. And at least in this paper, they sort of provide a data set to try and help future sort of legal scholars build such a system that would simplify that extraction process. I don't know if that answers the question, Vincent, but I'm happy to talk about it on Discord later.
So in like I can make an addition if you'd like.
Go for it.
So in my previous job, like question answering also in itself is divided into open book question answering, closed book question answering as well. And in my previous job, what we did was that we had this very big researcher team, and those researcher team was extracting. This is like an entity extraction kind of thing, but it was solved through question answering. That's what I have discovered. Where they had to like extract so many repetitive information from research papers. So I also tried using that one. I feel like there is so many ways, like so many combinations that you can model information retrieval, and question answering is also used very widely. And Heiko, who is by the way, he's from AWS, doing many nice notebooks for Hugging Face plus AWS. So he said, imagine you have to deal with a lot of text of the same structure. You can use QA models to retrieve key info from your docs. What is the start date for this contract? Like just what you have said.
Yep.
And Vincent said, sure, but if you have lots of contracts, wouldn't entity detection on the date be a more pragmatic approach? I feel like this is more of that falls more into a named entity recognition, where you can solve with tools like Duckling, where it extracts dates, email, names, etc. And Vincent asked, what is the intended use case, as in at what practical tasks do neural QA systems make a lot of sense practically today? I would say where your answer is not exactly passing, like where your question is asked differently than your context is exactly set. Like questions are not asked perfectly sometimes given in the context. So I would say if your question is not perfectly asked, with maybe synonyms and stuff, neural systems might actually work. But this is my opinion.
Yeah, and maybe just to sort of add another comment there is that, with entity extraction methods, like a lot of the things that question answering provides is the ability to get like a span of text. And I can do the same thing with an entity recognition system. I can kind of reconstruct a span given some entities. but yeah, maybe the trade-off is like how much post-processing do I need to do, or how many rules do I need to introduce to kind of combine, for example, the elements of an address together or something. But that's yeah. In terms of like practical use, is probably the length of the answer is maybe the interesting thing.
Yeah, like because it has the span itself as a feature like built in, that's actually nice. Omar asks, can you do QA from data such as tables or websites?
Yes, you can. So
there's Tapas model, right?
There's a famous model now called Tapas. Let's see. This is probably this one from Google. Oh, we don't have a widget. Is that right?
I don't know for Tapas if we have it. It's
here we go.
It's been, so, yeah, it's there.
So yeah, you can kind of do this. Here's a question: how many stars does the Transformers repository have? Here's a table, and you can compute, and it then extracts this. But talking to Niels, who's the guy who implemented this in the Transformers library, I mean, this is like a sledgehammer, right? on top of a task that you can probably solve with like one line of Excel or Pandas. But I think it's more a question of maybe in the future we start entering an interesting sort of space where asking natural language questions over very large tables is kind of interesting.
So another question is, how does QA relate to neural search? Can we say that the latter is QA applied to different types of data like pictures, visual question answering, I guess?
Yeah, I think neural search is kind of an umbrella term. It's probably maybe not as well defined as like things like, I mean, it's probably like data science, what is data science? And I think in the neural search domain, you could sort of say that anything that's kind of relying, on neural networks in some capacity is probably under that umbrella term. So if you're just using retrieval with DPR, that's probably neural search. And yeah, question answering would be a subset. Because it's the whole domain is also for images, right? I mean, there's a company called Gina which does a lot of nice search stuff, and let's see, they have where are these examples? So if you look at these examples, they have, okay, this has changed since I last saw it, but basically this is like the ability to search on images, on audio, I think a little bit, and also on text. So it's a very big umbrella term. Shall we?
Last question. There is so much questions, but let's take one last one. This one is
People
good.
took my jokes seriously about using their questions.
But it's fun.
Yeah,
I'm having fun.
I think today I would be happy if we just sort of also just chat and do these things, and all the code is in the course, so you can always look at it later.
So is there a multilingual approach for question answering yet? For example, a customer in Amazon could ask a question in Spanish for which an answer does not exist yet in the Spanish language in Amazon, but answer could exist in the international English Amazon.
That's a good question. So if we're talking about the extractive case, then the answer would probably be no. For example, if I ask a question and if we go back to our trusty picture, if I ask a question in Spanish and all my documents are in German, then the retriever is not going to do a great job at finding, first of all, relevant documents, but the reader, if it was only trained for German text, is going to have a very tough time figuring out how that question relates to the context. So what you could do is you could translate on the fly. So if you wanted to take your question, you could translate it into the target language. That would be one thing to do. The alternative thing to do would be to take like a multilingual kind of model, like let's say XLM Roberta, and this is a kind of very good starting point if your language belongs to one of the 100 languages that it was pre-trained on. So this is just like a BERT-like model or a Roberta model, but it's multilingual. So you can then fine-tune it on say your German documents, and then if you get if you have Spanish documents as well, then in principle it will do relatively okay on those as well. But the performance is much more dependent on sort of the differences of the languages. So at least when I've worked with XLM-R, if you have languages that are very different from the language you fine-tuned on, the performance drops pretty catastrophically.
I would actually say this is one of the cases where, like after you translate it, it's better to use something that is like similarity based instead of direct QA. As like this is just an opinion and an instinct. I have a little bit of experience with this, but yeah, I don't know if I'm right, but I just felt like it. Another one, are there any use cases papers that talk about were given a document? What are the questions that could be answered by this document? There is a modeling.
That's a great question.
This question generation sort of I seen it.
Yeah, I was thinking about, like T5 and stuff. Yeah. Yeah, so I think I can't remember off the top of my head of the papers that do this, but I've definitely seen examples where people, you frame the problem as a kind of sequence to sequence problem. So you say, here's my document and here's like a candidate question. So you have to build your own training set for this. And then if you train a model like T5 on such a corpus, then the model it's kind of like a translation task, right? It's kind of like your language is like your document and your target language is the questions. And then once you've trained this model, you can then in principle feed it new documents and then generate new questions. But I think the question that this person is asking is actually deeper than that. It's like just given a document, maybe
All
it's
the
more like,
possible questions, right?
yeah. And
Yeah.
that's like that's I think almost an impossible task.
I've looked up in the papers with code and it tells what you have said, but I swear I saw it somewhere that it says where it's generating answer candidates. Anyway, I'm going to find it and I'm going to post it on my Twitter at some point.
Well, you know what? Like, why don't we try?
Okay.
Let's see how T0++ can handle this. So maybe let's take a bit of text that we've got here from Wikipedia. So this is this text about the Virgin Mary, and let's feed it as the context. And then maybe we can ask what questions can be asked about this text.
I would be simple for this. Oh, okay. I thought
what is the name of
the statue for Mary? Oh, it did.
Yeah. But I mean,
okay. I love T0 for some reason. It's so good, and it did.
Yeah, I mean,
Okay,
it doesn't give us all of them. Maybe
but
it's like
maybe like if you could specify like 5 of them, maybe provide like
list of questions about this text. I don't know what it will do. Nah, okay. I think it's a bit stuck in its local minima.
Yeah.
But yeah.
Question. There is so many questions. What is an effective way to go from a passage to a question? In other words, generate a reasonable question. We just covered it.
Yep.
We got some good feedbacks and people agree with it. You should do more of these events often. I agree. I like spending time with Lewis a lot. Do you recommend doing a language model fine-tune before QA for these multilingual like if you are going to do multilingual things, do you recommend doing a language model? I don't know.
Yeah, so I think it depends on your target language. So one thing that I typically recommend you do first, if it exists, right? So let's suppose I have documents in German. So DeepSet, which is another question answering or neural search company, they have a bunch of different models, and I think from memory they have like, did they fine tune? Okay, maybe they didn't have one. Maybe it's GBERT. Yeah, here we go. Okay, this is just the base model. But basically what I wanted to say was that if you can find a model that has been fine-tuned already on Squad in your target language, that is probably a good baseline to start with. Because, even though these Squad models have tons of well-known problems, like, they're not really learning like how to answer questions, they take shortcuts all the time. They often do provide a good starting point for building a system. So, once you have this Squad model, you can at least improve it by fine-tuning a base model on your own target corpus. For the whole like generic multilingual case, I'm not aware of like many kind of fine-tuned like general multilingual models. So generally you will have to do something like take XLM Roberta as your base and then fine-tune it on your own corpus. The challenge I've often seen is that the labeling of data for this is very painful because, we see here that I need to provide like the span of text where the answer occurs. I need to index this. And, there are companies that will help you do that. But it's also a kind of known problem. How you generate the questions is quite a tough task. So, yeah, short answer, I think you'll generally have to fine tune the model. And the sad answer is that unless you're lucky enough to belong to one of these 100 languages that are covered by, say, XLM Roberta, then you're going to have to get pretty clever with regular expressions and, build a non-neural approach.
Bender rule.
Yeah.
A question for Merve, which relates to previous stream about sentiments and biases. Are there any work being done currently to tackle biases in QA? Is bias in QA being explored? I think this is more of a question for Vincent or Lewis.
Yeah, I think
I've never seen it.
Yeah, it's a very good question though, because I mean, you could imagine that. I'm just thinking like the bias that might exist. That's an interesting one. I'm just thinking about like if the question has like, for example, a certain name, maybe the most likely answer that is predicted is not the one we want. But I don't know. I'm not sure. Maybe Vincent can explain.
Maybe like if you can actually like find biases by testing it. Like for instance, you have these context text where it is saying something bad about, like it says something good about one race of people and it says something about bad about some race, and then you can ask a question and see which race it's like about a race and which race it's going to return. Maybe something like that. This is just a guess.
I think, and I think it's probably actually, now that I'm thinking about it, it's probably a similar bias question that we might associate with like other types of, let's say, search engines. So like, if I type something into Google and it starts giving me a very skewed set of results based on, some personal characteristics, that's not great. So
what I said was like for open book question answering where you are given the context, but for closed book question answering, which is something like what Google does, I guess, in the search engine, and it does actually return bad things about like people. I remember like what is the worst Indian accent returning something. What is the ugliest one? Something like that. I don't want to offend anyone, but it was something that I have literally seen. So in models like T5, maybe you could actually come across that.
Let's ask T0, is the world flat? So, I mean, maybe that's an example, right? Like
Yeah.
here we've asked a closed model for some answer, and that's a bias, right? It's or at least it's wrong. Maybe if T0 is trained on tons of internet text, there's probably tons of flat Earth blog posts that it's picking up on. Anyway.
Regarding dealing with imbalanced data set, if I have the same case but with array of tokens and array of tags, like for example NCBI disease, how would the proposed approach change?
Yeah, that's a great question. It's one that actually, the reason I had this quad paper was precisely for that reason. So let me show where it is. So one thing that can happen when you do extractive question answering is that if you have like let's suppose I have a piece of text and the answer doesn't exist in that text. So this can happen, imagine that I have a question like about the Virgin Mary, and maybe my retriever has given me a document about, Mary, some pop artist or something. So clearly there's no relevance in terms of the question and the answer there. And what the question answering models will predict is what's called the empty span. So they should typically say, we predict nothing for this answer, for this question. And sometimes what can happen is that if your documents are very long, you'll have to split them into many different passages, and you'll end up having a very imbalanced setup where the vast majority of the passages don't have an answer relevant to the question. And so the model will actually get the same kind of problems you have in text classification, where you end up predicting the empty span most of the time. So the trick that people typically do here is kind of like a down weighting. So this is sort of very similar to like when you are doing text classification, you might apply some kind of penalty or some weight factor on the examples that are in the majority class. But yeah, basically you do need to deal with this in practice, because the model will just get really good at predicting the most common feature. Let's see. So we have 5 minutes, Merve, and I didn't do any code, but we had some fun talking about things. Maybe, I know there was a question in Discord about domain adaptation, and maybe we could just talk about that for a few minutes. What do you think?
Sure. Sorry, my mic was closed.
Okay.
By the way, Victor is here, and he said oops for the T0.
Okay, so maybe just to wrap up with the last set of questions, that so one thing I was telling you before is that if you have access to a kind of fine-tuned squad model, you should like just use it as your baseline, and this will generally be okay as long as the text you're dealing with is kind of similar to Squad, which is based on Wikipedia. So these are like very factual based articles. But if you're doing something that is very different, then the performance will be really bad. So there's a nice paper called SubQA, which is a data set of subjectivity and review comprehension by these people in Denmark. And what they were looking at were, what is the impact when you've got kind of subjective reviews of products on Amazon? And this is like a much harder thing to measure, because subjectivity is a little bit in the domain of, like, say, sentiment. We don't really have clear, rigorous ways of quantifying that. But the interesting thing that I want to point your attention to is that they took kind of off-the-shelf models. So what you can see in green here is BERT, fine-tuned on Squad. So you can see that on Squad, BERT gets a really high score. But then when you try to apply it to these different reviews of different products on Amazon, which were specifically curated for their subjectivity, you can see that the performance is like abysmal, right? So suddenly you go from having an F1 score of like 80 or 90 points down to like, 20 or below. And so what they observe in this particular paper is that if you take your squad model and then you fine tune it a little bit more on the domain data, then you recover or you get a significant boost in your performance. So you can see that here, the grocery score for Bert with no just out of the box squad is below 25 points. And then once they fine tune on the in-domain data, they're able to, roughly double this performance. And so this is probably the last sort of thing to mention is that, question answering is a much more complicated beast than say classification, and classification is already hard enough. So you'll have to experiment a little bit on how do you get the best performance out of these models. I hope that answers that question.
Yeah. We can continue the discussion in Discord. Like if you have any questions, you can ask in general event chat room. And we should definitely do this more often. Next week, we can maybe continue a little with the question answering and then move on to another task.
Yeah, I think the most voted one after question answering was pre-training or training from scratch. Yeah. And I think that would be a fun one to talk about and maybe talk about some of the challenges that one runs into.
Thank you so much.
Thanks, Merve, and thanks everyone for the questions. It was a real pleasure, and see you at the next event.
Bye-bye.